All electrolyzers will consume water.
It's part of the reaction,
and it's generally the same amount of water in the electrolysis process. That's always the same, right? So for 1 kilo of hydrogen, you need 9 kilos of water, right?
Yeah.
If you're converting that completely, generally for systems, when you get to the stack, you supply a bit more, in our case, steam than is required. So there are some pass through in any case. The water that's split into hydrogen and oxygen, I mean,
same for everyone, right?
It's the same for everyone. The steam that passes through can be recovered because you're condensing that steam out.
So it's not waste. It's not wasted.
It doesn't have to be wasted.
Yeah.
That's right.
Yeah.
But then you've got to think, well, where's that steam coming from in the first place? You know, it's probably coming from an industrial process in the first place. So they would have sent that to a cooling tower.
So you can put it somewhere else at the facility, depending on the facility.
Indeed.
Yeah.
But look, you know, we're talking large amounts of hydrogen. That water's got to come from somewhere. So I think siting of electrolyzer plants, you know, clearly you have to consider that. And there's lots of different ways of looking at that. But you know, desalination of seawater, for example, or use of fresh water, they're all options. But it's very much going to be contextually based about where's the best place to get the water from.
Right.
I think SOEC actually uses less water than PEM, for example, and alkaline, because those systems have to manage their heat quite carefully. Heat's being generated in the stack, but you've got to maintain the temperature in the stack below a certain limit. So you're driving current through the stack, it's warming up. You need to control that. So those systems tend to have quite large cooling systems, which can use evaporative coolers, for example, which use a fair amount of water. And the nice thing about solid oxide is that we can, because we're running at a high temperature, we're bringing in steam in any case, but the heat generated in the stack can be used to offset the electrical input, and that's really where we get our high efficiency. So there's no active cooling of the stack components required. So I think in that regard, water usage for cooling requirements isn't there for
relevant.
solid oxide.
Exactly.